Good afternoon, everyone. Today I want to talk about something that might change the way you think about viruses. People hear virus and they think danger. It takes us straight back to lockdown and the COVID-19 pandemic. Zika and herpes, they're not exactly the kind of words that spark joy. But what if I told you that these viruses are being reprogrammed and used to fight cancer? Here's how it works. The virus is stripped of its harmful traits and rewired to specialized tools that infect cancer cells while leaving healthy cells intact. Once inside the tumor cell, the virus replicates, causing the cancer cell to burst open and die in a process called oncolysis. This destruction of cancer cells leads to the release of tumor antigens, which alerts and mobilizes the immune system to recognize and attack the remaining cancer cells. So the virus not only knocks out cancer cells directly, but also rallies your body's natural defenses to join the fight. The idea of using viruses to fight cancer isn't as new as it may seem. Over a century ago, doctors began to notice something strange. Some cancer patients who caught viral infections actually saw their tumors shrink. Patients with various cancers who had severe infections like measles or influenza saw unexpected tumor regression. By the early 1900s, scientists began wondering if you could somehow use these viruses as a form of treatment. This led to trials that involved injecting cancer patients with viruses like mumps, measles, or even the common cold virus. And surprisingly, some cases it did work. Tumors shrank and patients saw temporary improvement. But these early attempts were very unpredictable. Even though in some cases the virus did work, in other cases it made the patients even more sicker. That's because scientists didn't have the tools yet to fine-tune and control how the virus behaved in the body. And because of that, research on viral therapies slowed down for decades. But now with advanced genetic engineering, we can design these viruses to be very precise. And what was once a risky experiment in the 1950s has now turned into a more sophisticated and targeted cancer therapy. One major breakthrough in cancer treatment is T-VEC, the first FDA-approved oncolytic virus. It's been particularly effective in treating advanced melanoma, shrinking tumors, and boosting the immune responses. And what's even more interesting is that it works even better with certain immunotherapies, offering patients a more longer-lasting and effective defense against cancer. And this is not the only virus that holds promise. There's also virolysin, which is a real virus-based therapy that's being used to treat breast and pancreatic cancer, as well as Pexavec, which is derived from the vaccinia virus, which is being tested to treat liver cancer. There's also Oncolytic, which has been approved in China to treat head and neck cancers. Right now, scientists are trying to improve these viruses by engineering them to deliver cancer-fighting genes, improving how they spread across the body, and using them in combination with other therapies so that we can target even more types of cancers. And while these do hold great promises, there is still challenges and limitations. One major hurdle is delivery. Most viruses need to be injected directly into the tumors for it to be effective, which limits the use for cancers that have already spread across the body. The immune system also poses a challenge. Even though these viruses are designed to stimulate an anti-cancer response, the body may clear the virus too quickly before they can even attack the tumor. Additionally, some cancers may find it hard to be treated with oncolytic viruses, either because the virus struggles to infect the cancer cells or the tumor's environment is in such a way that it blocks the virus from working. For example, pancreatic tumors have a dense and protective barrier that block the virus from infecting these cells, while glioblastomas exist in the brain, where the immune system tightly controls what enters, and this limits the way the virus spreads and takes effect. But new research has found a way to overcome these challenges by using genetically modified viruses such as PVS-RIPO. This is a modified poliovirus that's specifically used to tackle these challenges in glioblastomas. Essentially, glioblastoma cells express high levels of CD155, which is a protein that polioviruses naturally bind to, and because of this, PVS-RIPO can easily latch onto and infect glioblastoma cells while leaving healthy brain cells alone. To tackle the problem of the tumor environment being too tightly controlled, scientists have swapped out the poliovirus's genetic sequence, a part of the poliovirus's genetic sequence, with a common cold virus sequence, and that weakens the virus's ability to infect healthy cells while still being able to replicate inside tumors. As I mentioned before, the word virus has quite a negative connotation. That fear can make people quite wary about the idea of using viruses as a treatment. Especially after COVID-19, people are very cautious about anything involving viruses, and misinformation can make that really worse. People may worry about the virus mutating, spreading, or causing dangerous side effects, even though these treatments are designed to be safe and effective. But that's why communication is so important. The more we educate people on how these viruses work and how they attack only cancer cells and not healthy cells, the more trust we can build. Real-life patient success stories, clear explanation from doctors, and strong safety regulations will all be key in making sure that oncolytic viruses gain public support. So why do oncolytic viruses matter? Well, cancer is something that affects so many of us in so many different ways. Nearly 1 in 2 people will be diagnosed with cancer at some point in their lifetime. And while traditional treatments like chemotherapy and radiation have helped countless people, they don't always work for every type of cancer and may have severe side effects. This is why researchers are continuously pushing boundaries, trying to find smarter and more effective ways to fight cancer. Oncolytic virus therapy is one of these major breakthroughs, harnessing the power of viruses not to cause disease, but just to destroy it. These modified viruses are used to attack stubborn tumors, boost the immune response, and offer hope in when options may seem limited. It's a shift in how we think about both viruses and cancer treatment, because these viruses aren't here to make us sick. They're here to save lives. Here's a bunch of my references, and that's the end of my presentation. Thank you.